All right. So, hello and welcome everyone. So, we are live right now. I hope I'm audible to all of you, right? So, welcome back to this amazing people on Tutee Learning. And today, we're going to discuss about the concept regarding the point and a straight line, right? So, today's class is going to be really an interesting class where we're going to definitely enjoy solving problems and also learning about the fundamental stuff, right? So please consider this particular lecture as a very important lecture because this particular concept is definitely going to help you out in solving different numerical problems in your JEE Mains. Okay, so I hope this is clear to all of you. Am I audible to all of you? Please let me know in the live chat. Am I audible? Clear to all of you? Right. So yeah, I hope I'm audible to all of you, right? So let's start with discussing about the concept regarding the point and the straight lines, right? So today, as we finished in our last discussion, where we saw the concept of parametric form of a line, or what we also call as the distance form of a line, right? So I hope that particular concept of distance form of a line was clear, right? So we also solved some numerical problems to solidify our understanding on the basic portion, right? Now, along with that, and we also studied about another important concept that was regarding the concurrency of three lines, right? So in today's class, we are going to discuss about the distance of a point from a line, right? So let us first of all start with discussing about the distance of point from line. Okay, so let us try to understand this particular concept of a point and a line, right? Or how do we find out the perpendicular distance of a point from a given line? Okay, so let us say I have a given line point that is given as x1 comma y1, right? Now this particular portion might seem very familiar to you because you already studied this concept in the plane, right? So this equation might look very familiar, and let us say the equation of the line is given as ax plus by plus c is equals to 0. Okay, so this is my equation of the plane or the line, right? So yeah, exactly, line in 3D is basically that of a plane, right? So how do we find out this perpendicular distance, right? Okay, so let us say this perpendicular distance is given as small d. So if you look by the formula, the perpendicular distance is given as mod of ax1 plus by1 plus c whole divided by square root of a square plus b square and mod of it, right? So if you apply this particular form, you are definitely going to get the solution for the distance of or perpendicular distance of a point from a straight line, right? So please try to follow this particular definition, and it is quite similar to what you have already seen or studied in the planes, right? Now let us try to see that how we can come across or how we can get out to this particular formula over here, right? Now the simple way to derive this particular formula would be just by considering maybe the area of the triangle, right? Because so how do I get a triangle? That's also a good question. It's quite a simple, so you can definitely do that by playing around with the geometry. Okay, so let us say that this is my coordinate axis, this is my x and this is my y axis, and let us try to draw a line equation like this. Now the line equation is given as so the line equation is given as ax plus by plus c equals to 0. So this is the equation of the line, right? This is my equation of the line, right? So if I try to find out the x and y intercept coordinates, then let us call this a and b. So the a will be minus of c upon a comma 0, and b will be 0 comma minus of C upon B. Okay, minus of C upon B, right? So this is what we will have as the coordinate of point A and point B. And let us consider that this point P is somewhere over here, which is given as x1 comma y1. So our perpendicular distance is this particular distance, right? So this is my perpendicular distance D. And so now if I try to form this particular triangle, so if I form this particular triangle by joining this coordinates like this, and let us call this point, so the triangle over here is triangle PAB, right? So this triangle PAB, if I try to find out this area of the triangle PAB, what I can do is that I can find out this particular area of the triangle PAB by using the concept of, so it will be equals to half into base into height. The height is D and the base is basically AB. Okay, so I will find out the distance of AB. Now in a similar manner, I can also find out this area of this triangle PAB can also be given as, like, if you try to find out the area of this entire quadrilateral and then subtracting this particular area of the triangle AOB, right? That is also you can do over here. So if I do that, that particular area would come out as half times. So let me put a mod over there, or maybe I can just, because I know the coordinates, I can use the formula of the area of the triangle. So if I do that, I'm going to get this relation something like this. So this is just by solving the determinant. Okay, so I hope you know what determinant I'm solving for, because we have already discussed on this part in our previous lecture. So if you haven't watched the previous lecture, please go back and watch the previous lecture before you are coming to watch this current lecture, right? And these two parts should be equal. So if you just equate this particular part and you carry out few lines of algebra where your y1 is nothing but ax1 plus c divided by minus of b, right? So that is going to be y1. So please try to plot that, and if you try to solve it by that particular form, because your AB, this particular distance AB is going to be square root of c square by a square plus c square by b square, right? So this is what your distance AB will look like, right? So from here you can take c square common and 1 upon a square plus b square will be left out, and that particular part, if you just try to solve the algebra, so you can do it this particular algebra by yourself. It is pretty straightforward. So from this algebra you will get that point distance of this perpendicular distance of point P from this line is going to come out as something as ax1 plus by1 plus c, and then divided by square root of a square plus b square. Okay, a square plus b square. All right, so this is going to be your final form of the distance of a point from a straight line. Problems as well, right, which will help you to understand eventually how we do this kind of derivations, right? Is this part clear? Do let me know if this part is clear or not. Okay, I presume this part is clear. So let us now also move towards understanding another important concept, that is the distance between two parallel lines. So in the similar manner, if I am asked to find out the distance between two parallel lines, I can do that easily as well. So this particular concept of distance between two parallel lines can be easily solved by taking any point on the other line, and we can then again find for the distance between them, right? So it is also very similar to that what you have studied in the concept of planes, right? Because straight lines in 2D and planes in 3D are the same thing, right? We already discussed about that particular concept. Now, so let us say we have two parallel lines. This is my one parallel line and another parallel line. So the parallel lines only differ by the constants. Okay, so this is the two parallel lines we have, and let us say this particular distance, so the perpendicular distance between two parallel lines is going to be d, because it's going to have the same distance throughout the entire domain. So I can easily do that question by assuming one particular point on the other parallel line and finding the distance of x1 y1 on this particular line. So if you do that, this perpendicular distance d would simply come out to be c1 minus c2 divided by square root of a square plus b square. Okay, divided by, and put a mod of it because distances cannot be negative. Okay, So this is how you will obtain the simple relation of the distance between two parallel lines. I hope this part is clear to all of you, right? I hope this part is clear. So let us try to see a very interesting problem on this particular concept, right? So let us try to solve some geometrical problem in order to understand our concepts in a much better depth. Okay, so this is the simple problem that I have for all of you. So before I start to discuss about the solution of the problem, I would request all of you to please go through the problem and try to give a try. Okay, so maybe you can try to apply whatever concept you learned throughout the chapter, and maybe you can apply those particular thing over here. Okay, and as we move on or proceed with the discussion in the further lectures, you will be seeing that these kinds of questions are very repetitive, as well as especially in the examination. Okay, so please try to focus on these kinds of problems a bit more cautiously, because these kinds of problems is going to sometimes make difficulty for people to understand and interpret the results. Okay, so however, so if you understand this particular concept at this particular moment itself, it is going to be very useful. All right, so please try to solve this problem. So again, a pretty straightforward problem, I know, but for someone it might also look a bit difficult as well, right? Okay, so if I go through the problem, if I try to read through the problem, what I see is that I will check over here that the question mentions that I have to find out or find the equation of the straight lines passing through this point -2 comma -7 and having an intercept of length that is 3 between the straight lines, which is given as this and this. Okay, so I have to find out the the equation of the line. I have to find out the equation of straight lines passing through this particular point and having an intercept of length 3 between these two straight lines. Okay, so what this particular question is actually referring to. Okay, so let's try to understand this particular problem, especially by drawing the geometrical figure of it, right? So if I try to look at this particular problem, what is this problem talking about is that, so if you look at these two particular lines over here, these two lines are parallel lines. Okay, so let me draw those two parallel lines over here. So my first line is 4x plus 3y is equals to 12. 4x plus 3y is equals to 12. That is my first line. Another line is 4x plus 3y is equals to 3, right? That is my second line. So these two lines are parallel lines, right? So these two lines are parallel lines. Now it is said that a line which is passing to this point P, which is -2 comma -7, right? So if you look it carefully, maybe some point P will be like over here -2 comma -7, and I have to find out the equation of this line which is passing through this point 2 comma -7 and having an intercept of length that is 3. So let us call this points as A point and B point, right? So if I look at what this basically mean by intercept is that this particular cut out of the distance, okay, this particular cut of the distance, that is the distance from A to B, is given as some 3 units. Okay, so this particular distance, the question is referring as 3 units, right? So, but please note that this is not the perpendicular distance, right? However, it might have some angle, right? So if I try to understand this is a perpendicular form of the distance and this particular angle, let us call it some alpha. Let us call it some angle alpha over here. So how do I find out this particular problem? So let me first of all find out this perpendicular distance between two straight lines. So this perpendicular distance can be given as AL, and that can be easily found out by our formula. So if I do that, so it is going to be it is minus of 3 and this is minus of 12. So minus of 3 minus of minus 12, that is plus of 3. Ultimately I'm going to put a mod, so it doesn't matter. And then square root of 4 square plus 3 square, right? So if you just solve this problem, so your perpendicular distance between two parallel lines is going to come out as some 9 upon 5, right? Some 9 upon 5. So from this right angle triangle, what I can notice is that I can easily formulate my AB square is equals to AL square plus BL square, right? AL square plus BL square. I already know what is my AL square, and AB distance is known to me, right? So I have to find out this BL distance, right? So if I do that, I will find out my LB or BL distance to be coming out as 12 upon 5. Okay, so this particular distance will come out as some 12 upon 5, right? So once I get this particular distance, I can easily find out now my so-called and also one more thing I can note over here is that this particular, I need to find out the slope of this line AB, right? So I need to find out the slope of the line which is making some angle alpha, right? Now this alpha I can find out as tan alpha in this right angle triangle would be the perpendicular upon base, so that is upon AL upon BL. So this will turn out to be some 3 upon 4, and this particular angle is also equals to mod of m, that is the slope of the line of the unknown line, minus the slope of the parallel line, that is going to be minus of minus 4 by 3. So and then whole divided by 1 minus 4m by 3. Okay, and then if you put a mod over here, so if you solve for this equation, it will give you two values. One is infinite and another value you will get it as minus 24 minus 7 upon 24. Okay, so one of the value will come out to be infinite, which basically means that it is the other parallel line. Okay, but so, and this particular value of m, which is finite, is definitely going to give you the straight line AB, or the line passing through this point P. Okay, so this was the point P. So then I can easily formulate the equation of the line through P, through my point P, that is basically my AB line, right? So I can easily formulate this AB line. So one of the form of AB line with infinite slope would be like x plus 2 is equals to 0, and another form will be like 7x plus 24y plus 182 will be equal to 0. So these are the two equations that is possible for the AB part over here. Okay, so the equation of the line AB can be these two forms, right? I hope this is clear to all of you. I hope this question is clear. Do let me know in the live chat if this part is clear or not. Is this part clear to all of you? Is this part clear? Okay, so this is how we actually solve problems of this kinds. Okay, so these kinds of problems are very common, especially in the JEE Mains paper. Okay, so it is not a very straightforward problem. So you have to find out the slope of the unknown line by using the concept of the angle between the line, and to find out the angle we have to first of all find that particular distance, and by using the triangle we can formulate for the trigonometric relations, right? So that is what was basically asked in this particular problem. Okay, I hope this problem is clear to all of you. So let us proceed with the next topic. So what I will do before I proceed for the next topics, I would like to give you some more problems as an homework problem to practice, because this particular concept of this distance between two parallel lines or points and all these concepts are very, very crucial, especially if you are looking in for JEE Mains, right? So please try to solve this problem as a homework problem. Okay, so these are the homework problems. So please try to solve these problems along with the previous problems. So, and do let me know if you're having any issues in solving any of the problems. Okay, so these are the following 4 problems which is definitely going to help you understand this particular topic in a much deeper way. Okay, so I presume this particular topic is clear to all of you. Okay, so let us now move forward with our discussion on this particular concepts. Okay, so let us consider moving forward with our discussion on the similar concept. So now we're going to learn. So I hope you have taken a screenshot of it. All right. So let us now start to learn about another important set of questions that is relating to the position of a point relative to a particular line, right? So this is a similar concept that we have already learned in the position of a point and a plane, right? So position of a point relative to a line. Okay. Now, why is this problem important? Because we are going to definitely discuss about the angle bisector. Okay, so in this particular concept is going to play a important role. Okay, so position of a point relative to a particular line. Okay, so let us try to understand what do we actually mean by the position of the point related to a particular line, right? So this particular concept means that if we, let us say, we have some line whose equation is given as ax plus by plus c equals to 0, and we know, let us say we have two coordinates. Okay, let us say P point is given as x1 y1, and let us say we have another point Q which is given as x2 y2. Okay, which is given as x2 y2. And if we have this particular 2 points in our question, the coordinate of point P which divides this line, so let us say this is a line joining point P and Q, and let us consider any point that is lying on the line ax plus by plus c equal to 0 as R, and this particular point is dividing this line segment PQ in the ratio m is to n, right? In the ratio m is to n, right? So how am I going to decide whether my point P and the Q point is lying on the same side of the line, or whether it is lying on the opposite side of the, like the 2 points are basically lying on the opposite side, like as in this case, okay? Or maybe it might be a question where the point P and this point Q are lying on the same side, right? So how am I going to judge that particular thing? The judgment is very simple. If I solve for this point R, if I solve this point R by considering some ratio, let us say lambda is to 1, and if I end up getting the value of lambda to be a positive value, if I end up getting the value of lambda to be a positive value, that means, and also please note, I solved this R point by considering it lying on the line, this particular line, right? So if I get a positive value for lambda, that basically implies that this point P and Q are basic, and this R point is an internal angle by internal bisector or internal section division, right? If this particular point, if I divide this particular point R, or this point, this line PQ is divided by point R such that this R point lies outside this region of PQ, then that basically means it is an external division, right? So in external division, I will obtain that ratio to be coming out as some negative ratio, right? So external division, and in this case we'll have an internal division, right? So in this case, when I have an internal division, I will see that the ratio is going to be positive, whereas in this case of external division, the ratio will come out to be negative, right? So depending on this, I'm going to judge whether my point P and Q are lying on the same side or lying on the opposite side, right? So if I do out and carry out that particular algebra, if you find this particular ratio, that is, just put this particular points in this line equation and find out the form. So if you look at this particular value and divide by the, okay, so if you get this particular ratio to be coming out as positive, that basically means, so if this point R is between this point P and Q, that is point P and Q are on the opposite side of the given line, then this ratio should turn out to be positive. So if you just have this particular case, then in this case, this particular ratio of the line distances of the form of the ratio will come out to be positive. So what you can understand from here is that if both of them are of the same sign, right? If both of them are of the same sign, then that is basically lying on the same form. Whereas in this kind of case where you have an external division case, in this particular form, you will be getting the ratio to be negative if you consider by internal division, and then if you obtain this particular value of the ratio, okay, if this ratio turns out to be negative, in this case you can say that the point P and Q are lying on the same side. That means these two values are basically of the opposite sign. Okay, so if I have the same sign, they are basically lying on the opposite side, and if I have the opposite sign, then they are lying on the same side. This is very uh, uh, interesting concept, and I hope you are able to understand this particular thing in detail, right? So why do we need to learn about this particular concept of a position of a line or a point related to a particular line? Because in the questions upcoming topics, we are going to discuss about the angle bisectors, okay, or the equation of the bisector of two lines, right? In that particular case, when we are going to judge between that whether this particular bisector is the interior angle bisector or the exterior angle bisector, we are definitely going to use that particular concept. Okay, I hope this is clear to all of you. Is this part clear to all of you? Please do let me know in the live chat. Is this part clear? Is this part clear to all of you? Please do let me know in the live chat. Okay, I can repeat it again if it is not clear. All right, so I presume this particular part is clear. So then we can move forward with discussing about another concept, that is basically the concept of angle bisector, right? So today let us also introduce to the configuration of angle bisector, or how do we find out the angle bisector, right? So maybe in the next class I would definitely going to discuss how do we judge whether the bisector is an interior bisector or exterior bisector, right? So for the time being, let us introduce ourselves with the angle bisector concept, right? So if I have two lines, let us say this is my line 1 and this is my line 2, this is my line 1 and this is my line 2. So in this case, if I find out this particular angle bisector or this particular angle bisector, these are basically known as the angle bisectors of two given lines, right? So the angle, when I talk about the angle between two lines, I have already explained to you this particular concept is that the angle between two lines can be this particular angle or it may be this particular obtuse angle as well, right? But which angle am I considering, that will determine that what kind of bisector I'm looking for. So if I'm interested in the acute angle bisector, then if I am looking for the acute angle and I bisect that acute angle, then I'm going to get the interior angle bisector, okay, or acute angle bisector. That's what we call, right? Or we call this as acute angle bisector. Or if I am looking at the obtuse angle and I bisect that particular angle, then I will get the obtuse angle bisector. Is it clear? Now, how do we find out this angle bisector concept? The concept is very simple, right? What do we actually mean by angle bisector is that angle bisector is the locus of a point which is having the same distance or which is equidistant from the two given curves or the two given straight line. So if I take up any point, let us say x comma y, that is lying on the angle bisector, and I try to plot the perpendicular distance of it, and that particular distance must come out to be same. So let us say my equation of line 1 is given as a1 x plus b1 y plus c1 is equal to 0, and my line 2 is given as a2x plus b2y, a2x plus b2y plus c2 is equal to 0, plus c2 is equal to 0. So these are my two lines, right? These are my two equations of the two lines. So if I just find out the perpendicular distance from this point or this variable point x comma y, and if I just equate it, I'm going to easily get the equation of the angle bisector. So that particular equation of the angle bisector would turn out to be something like ax1, a1x1, or maybe like, sorry, x is there over here. So it is ax plus b1y plus c1 divided by square root of a1 square plus b1 square, and if I take a mod of it, or I will be replacing the mod with the plus or minus sign, right? Because this plus or minus sign will indicate my two bisectors, right? It might be an acute angle bisector or it might be an obtuse angle bisector, right? Okay, so this is what is the concept of the equation of the angle bisector. Okay, so this is how we are going to definitely find it out, the angle bisector concept, right? Now another very easy way to judge whether I'm finding out the acute angle bisector or the obtuse angle bisector is find out the equation of the bisector with these two signs. Okay, use the plus sign and use the minus sign, find out the angle bisector. Once you find out the angle bisector, what you have to do is that you try to find out the angle between the two angle bisectors. So if you try to find out this particular angle, that is theta, and this is called as theta 1, or maybe theta and this particular angle as phi. Okay, you take the two forms, that is plus form and the minus sign, and you will get two equations on the line, that is either this line and this line, and you try to find out the angle between this line and the line 1, or this particular line and the line 1. So if you do that and you find out, or what you can also do is that you have to check whether if you take up any point on this particular form, or maybe you can take 2 points, and if they are having the same sign or opposite sign, based on the basis of that particular thing as well, you are going to judge whether this particular line is an acute angle bisector or an obtuse angle bisector, right? So if you are confused out with this particular stuff, we are definitely going to discuss about it, don't worry. Okay, but it is quite a simple idea, right? So because this particular angle is theta, let us say this particular angle is theta, so it is going to be theta by 2, right? It is going to be theta by 2. So if I'm saying that theta is less than pi by 2, then my theta by 2 should be less than pi by 4. So you try to find out the angle between the angle bisector and the line 1, and if you find out that particular angle turns out to be less than pi by 4, that is 45 degree, then that basically means that you have found out the acute angle bisector. Okay, acute angle bisector. And if it is not, and if it is greater than, if that particular angle comes out to be greater than 45 degree, then that basically simply implies it is an obtuse angle bisector. Okay, it is simply an obtuse angle bisector. Okay, but in the next class we are also going to discuss about that how we can use the concept of the position of a point related to a line to judge whether it is my acute angle bisector or obtuse angle bisector. I hope this particular concept is clear. Okay, so this is a very simple technique to judge whether we have an acute angle or obtuse angle. However, there is another very relatively easier method or a shortcut technique to judge basis on a sign scheme, right? So that we are going to discuss in our next class. So for the time being, what I can do is that I can make you all busy or occupied with judging whether we are going to get an acute angle bisector or obtuse angle bisector, right? So please try to solve this problem and try to struggle with this particular problem in order to understand this particular concept in a much better way, right? So please try to solve this problem as an homo problem and try to struggle with it, okay? Because unless and until you struggle with any particular question, you're never going to learn that particular thing in a better way. So if I'm going to throw away all the concepts to you and say that if this is there, then this happens. If I'm going to spoon feed you, then definitely you're not going to be very effective in applying the concept to the different types of problems. However, if you struggle with the problem and then you come back to understand the concept, in that particular way of understanding would be a better understanding, and you are definitely going to do better in unknown or random questions. I hope this is clear to all of you. So please try to solve this problem as an homo problem and do let me know whatever answer you are basically getting in the comment section. Okay, so with this I would definitely like to conclude my session over here. I hope I was clear enough to explain you all the important concept, and definitely basis of this you're definitely going to solve the JEE Mains question as well, right? So we are left out with only some few more topics, that is regarding the family of planes and then or the concept of a mirrored image of a particular point with respect to a line mirror, right? So those two particular concepts of the foot of perpendicular are basically being left out, right? So I'm definitely going to cover those particular things in detail in our next class, and then we are going to start with our entire concept of considering the conic sections, right? That is the pair of straight lines, right? So pair of straight line is going to be a really interesting topic. However, family of lines is also very important, especially if you're for JEE Mains, right? So in JEE Mains paper, you can find a lot of question has been asked on the concept of family of straight lines. Okay, so with this particular thing, I would like to conclude my session over here, and I thank you for your wonderful attention in this particular lecture, and I hope to see you soon in my upcoming